on those ones. Okay, so the next one, finding the slope. So that means you're probably, if you see anything that looks like this that talks about slope, you're probably dealing with a perpendicular. So that's either the altitude or perpendicular bisector, because the slope has nothing to do with midpoint. So if it walks you into the word midpoint, you want to think perpendicular bisector maybe, and then median probably more than likely. Most of the questions I've seen have been more along the lines of perpendicular bisector. So we find the slope of AB. So it's a 10 by 4 again, remember like we already did. So 10 by 4, which you would want to reduce 5/2. And then BC is 8/4, which is a 2-to-1. And last but not least, 8-to-2. Oh, and I got that backwards, sorry, guys. That's to run 8 3 1/4. And for that matter, this guy's going to be negative. So it's going down. So now I have the slope of a line. What would the slope of a line perpendicular be? And that's remembering that perpendicular lines have an opposite reciprocal slope. So opposite reciprocal means the opposite reciprocal for this guy is going to be a negative 2/5. Our opposite reciprocal for BC is going to be 1/2. The opposite reciprocal for AC is going to be 4-to-1, 4/1. And then draw a perpendicular segment to angle C. So if I'm going from angle C and I want to go straight down, that means from this point, I'm going perpendicular to AB. So that means I need to go negative 2/5. So negative 2/5. Sorry, I did that wrong. That would be positive. Negative 2/5, which would be going this way, up to over 5. That is definitely not perpendicular. Am I making a silly mistake right now, guys? Or is it just, actually, you know what it is? It's the graph itself is stretched, and they're not square, they're rectangular. So it's not, it doesn't look perpendicular, which I guess is actually a pretty good, because this graph is wider than it is tall. I think if I change it though, it's going to mess up. Yep, everything we got. So the reason you know this is perpendicular, even though it doesn't look like it is the opposite reciprocal slope of this. Even though it's stretched, at this point we know this is not going to be the same. So it's not a bisector. So this has to be an altitude. So what would the slope of a line perpendicular to BC be? Remember that's 1/2. And we're going to start it from A and go to 1/2. So up 1/2, up 1/2, up 1/2, up 1/2. So again, it's not bisecting. So that's how you know it's not a perpendicular bisector, that it would be an altitude, because it starts at a vertex and it's 90 degrees with the other side. And again, I apologize, I didn't think about that last night when I made these slides. This one was a little stretched. But you know it's because it's 1-to-2, 1-to-2, 1-to-2 versus the negative 2-to-1 of BC. And then last but not least, what is the slope of line AC? The perpendicular, so you won't want it perpendicular to AC. So we're going to go 4-to-1 from B. So positive up 4/1, so that would be down 4/1, down 4/1. Oh, negative, because the first one was positive. All right, so then this is, they're all altitudes. This is going to be your orthocenter. Now this one, for me, and I've typed it up on the next slide, because it starts at a vertex, then it makes sense to me that this can't be equidistant from the vertex, because obviously this guy is not the same as this guy or this guy. The vertex to orthocenter, vertex to orthocenter, vertex to orthocenter. But if you make a perpendicular line, when done correctly, it should be, I'm lying, orthocenter is nothing. We don't use orthocenter at all. This is the one that, as long as you know an altitude is an orthocenter, it's not an applicable point of concurrency at all. They don't use it for any questions for you to solve anything. It's just basically, you know, altitude orthocenter. Perpendicular bisector. So now it's going to actually, these are squares, so hopefully this will be better. So the midpoint of AB, we know is right here, and that's going to be our E, F, and G. So again, once it discusses midpoint, you should think median or perpendicular bisector. We knew this is a 5 by 2, positive 5 by 2. It's got to be a negative 2 by 5. This guy was a 4 by 2, negative 4 over 2. Which is a negative 2 over 1, which means it's going to be a positive 2 over 1 for a perpendicular to this one. This one's a 1 over 4. So the perpendicular is going to be negative 4 over 1. So what will be the slope of a line perpendicular to AB? Again, that's that negative 2 over 5. Slope of a perpendicular to BC here. And then perpendicular here. For perpendicular bisector, it does not have to start at a vertex. It just has to cross through these lines because this has to be equal to this. So those midpoints do matter. So you're going to start like perpendicular to AC. That's that negative 4 over 1. So you'll go here and go up 4 over 1, up 4 over 1. And that would be your perpendicular bisector. Again, for perpendicular to AB, perpendicular bisector. So AB is going to be that 5 over 2. So we got to do the opposite, down 2 over 5, down 2 way over, up 2 way over. So again, I'm going to go through the ones I can see. Something about like that. And those are going to be our perpendicular bisectors. And then F, it's going to go up 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and we go all the way out here. So that's your perpendicular. This is your circumcenter. And its location, so this is the one I was going to start the story. So this one, the perpendicular bisector, it has nothing to do with the angles at all, but it is going to be equidistant to the angles from that point. So here to here should be, if drawn to scale, the same distance as here. Oh, it's going to let me do it. To here. And then you should be able to move it again, slide the whole thing, and it should be equidistant to there. If everything's drawn to scale appropriately. So perpendicular bisector. So the biggest takeaway is median. It starts at an angle and bisects the opposite side. That's your centroid. Vertex of centroid is 1. Centroid to side is 2. So that 2 to 1 ratio. Perpendicular bisector only bisects the side at 90 degrees. It does not have to start at an angle. The circumcenter. And if you put the points of concurrency in order, the centroid, circumcenter, incenter, orthocenter, the catchphrase that I've seen is my parents are aliens, and aliens being the AL. But it's also because these are in alphabetical order. So my parents are aliens if you know centroid, circumcenter, incenter, orthocenter. So as long as you have those words floating around in your head somewhere, you should be able to match them up. And then hopefully we can attach the equidistance from vertices, equidistance from sides, and things like that. Angle bisector is pretty self-explanatory. Hopefully it starts at an angle and it splits that angle into two equal parts. You can't do that on a coordinate plane because you would need a protractor because it's not slope or midpoint. That's literally the measurement of an angle, and that's why that was not in that activity. Does anybody have any major pressing questions about these? Like I said, they're not going to be a big push right now, but just know as much of it as you can retain would be helpful. Okay, cool. I'm trying to stop the video. Oh.